Okay, this final video is looking at question 5. And the first part of question 5 is asking us to describe how crude oil is separated into fractions. One can obviously see how this could be extended to an AO2 style question by explain and suggesting limitations of that experiment. Right, so how it's separated, the described question, is it's separated according to its boiling point. So crude oil is a mixture of several hydrocarbons. The shorter chain hydrocarbons, such as liquid petroleum gas, will have a lower boiling point and therefore float up to the top of the fractional distillation chamber. Longer chain molecules, such as kerosene and diesel, will require more energy to boil and therefore they will boil off last. As they're boiled, they're then condensed and isolated into their individual fraction because each fraction has a different boiling point. One can automatically see how this could be extended to an explain style question, such as explain the reasons why they have different fractions, and that's due to the intermolecular forces. The larger the molecule, the more the intermolecular forces there are, and therefore the larger the boiling point it has. One could also see how that impacts their viscosity and their flammability. Well, if there's more intermolecular forces, they're going to be more viscous, so more thick, and so that means the viscosity is going to increase. And if they're more thick, that means it's more difficult for oxygen to get in and react in the correct orientation, remembering from your rates of reaction topic that not only do they have to be of sufficient activation energy, but they have to be of the correct orientation. So therefore, they're less likely to combust and they're going to be less flammable as you go down the fractional distillation chamber. So diesel would be significantly less flammable than petrol. And obviously that's a limitation of diesel, as we know, so one could again see a potential extension question of comparing the use of diesel with the use of petrol. So diesel is much more likely to lead to an incomplete combustion than petrol is, and hence why the car tax on diesel, previously there was an exemption because you could travel further on 1 mole of diesel than you could on 1 mole of petrol. So previously diesel was seen to be more environmentally friendly because the amount of carbon dioxide produced per journey was much less. However, we've now discovered that it's also much more likely to lead to incomplete combustion, producing much more carbon monoxide, and therefore some of the environmental benefits in terms of global warming can be outweighed by the potential poisonous hazards of the production of carbon monoxide. So a further potential question may be to suggest why the government are removing the car tax exemption for diesel cars, and it's because the diesel fraction is much larger in terms of chain length, and therefore the chances of incomplete combustion are much higher, and therefore the chance of production of carbon monoxide is much higher. In the final part of the question, it's looking at fuel oils, one of the fractions, power stations using it to convert it into electricity. Suggests how the use of suspension of limestone decreases one environmental impacts that wake gases would cause. So the most obvious answer here, I feel, is that waste gases can cause sulfur oxides and nitrous oxides. They can also form carbon dioxides. The problem with sulfur oxides is that they can produce acids, and those acids would lead to acid rain. The same with nitrous oxides, they can lead to nitric acid, and again that can lead to acid rain. Limestone is a base, and therefore it's going to act by reacting with the acid to form salt, water and carbon dioxide. This is obviously an application question because you know from your qualitative tests of negative ions that the reaction with acid to produce carbon dioxide is a test for the carbonate ion. So it makes sense that carbonate ion would react with any of the acid rain and stop that being a future problem. One of the other potential solutions was that you could react the limestone with additional carbon dioxide, and you knew from your question 3b that would then lock the carbon dioxide in the sedimentary rock, removing the carbon dioxide from the atmosphere. So that was an alternative potential answer.